How does a car's air conditioning system provide cool air during the hot summer? This is the car air conditioning compressor. The compressor is connected to the engine's crankshaft through a pulley, which drives it to rotate. The pulley of the compressor is separated from the input shaft, so it does not rotate together with the shaft automatically. Inside the pulley, there is an electromagnet that can generate a magnetic field. On the outside of the pulley, there is a pressure plate, which is connected to the compressor's input shaft through splines and can move back and forth. When we turn on the air conditioning, the electromagnet generates a magnetic field that pulls the pressure plate onto the pulley. This connects the pressure plate to the compressor's input shaft, and the pulley can then transmit rotation to the shaft, starting the compressor. When the compressor is running, it compresses low-temperature gaseous refrigerant into high-temperature, high-pressure refrigerant. Inside the compressor, an axial swash plate piston structure is used, which, driven by the pulley, makes the pistons move back and forth continuously inside the compression chamber. When the piston moves backward, the cold refrigerant enters the compression chamber. When the piston moves forward, it compresses the refrigerant strongly, turning it into high-temperature, high-pressure refrigerant, which then leaves the chamber. Behind the compression chamber is a flexible metal plate. On it, there is an intake valve that opens under the suction force generated when the piston moves back, allowing the refrigerant to enter. The plate also has a ring of exhaust ports, each sealed by a yellow exhaust valve. When the piston moves forward, the refrigerant is compressed. Only when the refrigerant reaches a certain pressure will the exhaust valves open, releasing the high-temperature, high-pressure refrigerant. This process repeats continuously, allowing each compression chamber to keep compressing refrigerant in cycles. The hot, high-pressure refrigerant then flows out through the compressor's piping and into the condenser. The condenser contains many fins to help dissipate the heat from the refrigerant. Behind the condenser, there is also a fan that, when rotating, cools the refrigerant further, turning the hot, high-pressure gas into a medium-temperature, high-pressure liquid. After that, the refrigerant passes through a receiver dryer, which removes moisture and impurities. Then, it flows through a pipe to the expansion valve. When the high-pressure liquid refrigerant passes through the expansion valve, it suddenly spreads out, causing its pressure to drop sharply and lowering its temperature to about 10 degrees Celsius, 50 degrees Fahrenheit. The cold liquid refrigerant then flows into the evaporator, which is usually located behind the dashboard. As the refrigerant circulates through the evaporator's coils, it absorbs heat from the surrounding air. A blower fan draws in the warm air from inside the car, passes it through the evaporator where it is cooled, and then sends the cooled air back into the cabin through the dashboard vents. During this process, the refrigerant inside the evaporator absorbs heat and changes back into a gas. This gaseous refrigerant then returns through the pipe